We're going to be talking about mainly the test plan and report, and then some other variations that you can do. Have you ever written a test plan? Any one of you? We have. And how much effort did that take?
Quite a while.
Yeah, quite a while. We're going to look at some of the things you need to consider specifically on it. And how about the report? Now, the report they're both very important. They're extremely important because that can be the life or death of what happens to you specifically. So let me advance over to the next slide here, where we talk about the test plan. These are things that you need to actually put within the test plan itself. And again, we're talking about the test plan. We've mentioned this before. Should this be cut and paste?
No.
Absolutely not. It should not be cut and paste. This presents kind of problems. There may be certain problems you have. Example, Gem 2. What are some of the problems you had with your engineer cutting and pasting?
Just by carrying over test specs from one to the other, they overlook changes in the testing.
Okay, so you ended up getting the whole wrong test plan basically created because of that.
Yep.
And so rather than saving time by cutting and pasting, it added time. And I'm not sure in that particular case, was there a situation where you added maybe a week to the time to be able to do it, or did you just prod forward?
Well, there's a delay in getting the correct tests that you're supposed to do. And that's not always easy because all the engineers aren't always accessible that we use.
So it can be days then, can it?
Yes.
It can be days, and that's the point, is that if you don't do a proper test plan, it can be days to act from when you want to get started to where it can be accomplished. So in this test plan, you need an introduction. And what do you think the introduction should have with it? Any ideas?
Scope and objective.
Scope and objective, okay.
Probably a description of the product.
Good idea, description of the product. What would you think?
Location of testing.
Okay, well actually you incorporate that. You're talking specifically the introduction. Or it's a general introduction of what you're trying to do, right? Specifically on that. And is that one paragraph or could it be several pages? If you look at some of the stuff you looked at before Gem 1, how long was the introduction typically on the stuff that you put together?
A lot of times it depends on the author and how verbose they want to be. But, oftentimes the more information the better. It can help with the way you set up a given test.
Okay, absolutely correct. More information the better. Okay, so once you've done your introduction, then you have to look at the documents that are applicable to this particular test. It could be certain test procedures. It could be some internal documents that you've written. It could be a variety of different notes, things like this. So you're referencing these particular documents. And some of the documents that you've seen referenced, Jim, I'm thinking in the other way, right? Jim 2. This is what happened, guys, when you get guys. Imagine if there was all 4 named Jim. That'd be something else, wouldn't it? What are some of the things that you've seen in the test plan that referenced? Is it just one document or several?
Several.
Several. Can you give some examples of maybe what it was?
Well, we usually reference back to the CE standards.
Okay, CE standards, which is obvious.
And then
Yes.
some of our proprietary standards as well.
Okay. So every document that applies in this particular test is referenced there on that. And then once you've done that, then you actually are going to talk about, as you can see on the third bullet coming down, the test location and site description, right? All right, where is it going to be tested? Are you going to do it internally or are you going to do it externally? You know, so gee, if it's going to be done externally, why do I have to do this? Well, you got to tell them what to do. Because they're going to do the easiest possible thing that they can if they don't have this arrangement here. Now, your case, Tom, you actually do pre-compliance mainly there. And do you actually come up with a test plan for that?
The technicians don't, but the engineers.
So they do come up with a pre-compliance test plan. So even though you're not doing it officially, you need to be able to define what you need to test. And pretty much the same stuff has to be put in there. In fact, you'll notice that there isn't any reference to a specific standard like CE or mil spec or anything. It's done for both. It's done for all the testing you have to do as far as this test plan being laid out. And then you have the location and the site description. If it's going to be done off-site at another location, you have to describe it entirely. And another thing, if you're selecting a particular person to do it, then you might even reference the individual. You maybe met them before and that kind of thing. And then the actual test instrumentation is going to be used. Spectrum analyzer. Is that enough? Spectrum analyzer? What do you think?
No.
I don't know that you would necessarily need to specify a model or a brand, because then, I mean, you may be going to a test house that already has a certain spectrum analyzer set up, but you're probably providing, hey, we need 30 kilohertz up to 30 megahertz.
Okay, a general specification.
Right.
What do you think about that, Jim?
Well, you need to, kind of what he was alluding to, you need to have, say, what type of equipment you need, but also what kind of capability.
Or capabilities, that's correct. And of course, you're saying you don't know really what kind of spectrum analyzers are going to be used. But in reality, if you know what it's going to be used, put it down. And not only do you put down the model number, but you put down the serial number. And why would you want to do that? You should know that, Sergio. Why would you want the serial number and model number and everything else? Calibration and checking and things of this nature. Plus the fact you want to make sure that you have something that's in very good shape specifically. So you actually put a lot of information describing what the test information is. Then the device under test. You have a description of what it is, all the necessary software that you need. You've got to have that kind of thing set up. And then, of course, the hardware and the cabling. Now, what did I tell you earlier about this situation with respect to cabling? You remember?
Provide it yourself.
Provide it yourself. Make sure you get the right cabling, because what's going to happen to the technician that's putting this all up, or even the engineer at the facility, or even yourself specifically, if you send it on site to another location? They're just going over to the box and pick a cable up. It might have bad parameters. You may not want it, so you need to really describe everything. And of course, you need to address different configurations that you might have. It's used in different configurations and things like that. And then device under test setup. Now, what do we mean by that, do you think?
What condition
very
the device
good.
has to be in during testing?
That's absolutely correct. You need to specify the conditions, the things you want to do. It's almost like an initialization phase, isn't it? How long you need to warm it up. In fact, some of the specs themselves actually will define that. But if you want to make sure it's done, you incorporate it in your test plan also. So you put all this kind of information in there. And then this specific test procedure. You may want it to be actually follow part of it, but you vary it a little bit. So you need to specifically put down what test procedures you want to go. And then at that, you also put the acceptance criteria that exist that you must have. And then you specify the report requirements. Now, if you look at some of the stuff you've done, Jim, what kind of things do you talk about as far as what the report requirements that you have? How about you?
Well, we'll take EMI for example.
Yes.
I might say I want to see, all of the graphs of the radiation or the radiated emissions testing to see, for all the different frequency ranges and see how close I was. I don't just want a statement saying that it was compliant.
Very good. Then you need to put that down in the specification, don't you, to make sure that does in fact get done. Don't leave anything for chance or question. That's the worst thing you possibly could do. And once you have all this information, now they're able to do the actual report, the test itself. So it's very complete. So it's important that you spend a lot of good time on this to develop it. Now, once you've done your testing, now you've got all this information. You've followed all the kinds of things that are existing there. And so you have to have a test report or certificate. Now, when you talk about a report in this area, are we talking about 1 or 2 pages? What do you think? All right. Jim, how big have you seen some of them?
It might have been huge. I think a lot of ours end up being over 100 pages.
Over 100 pages.
All of the reports. And this is across all of our environmental testing.
Yes.
So EMI is a large chunk of that, but you would also include thermal and shock and vibe and
Yes, you've got all this. So your reports are very well much larger than 100 pages. I think one other person told me in a class that they had a report that was over 500 pages long, literally. It took a lot of photos. You know, it's kind of like, remember you used to see in school, effectively, you get, the heavier the paper was, the better grade you get. So with a camera, boy, you can really make that thing heavy. So, again, I told you before that you need to take lots of pictures during this process. In fact, you might even in the test description as far as that, retell what photographs you want. Things that you want to do as a minimum on that. Now, Tom, in your case here on the report itself, do you or the engineer have to prepare a report on your pre-compliance testing?
Engineering prepares a report.
They do a report, but in reality it's not required, is it?
No, it's not required.
It's not required at all.
We'll give them the data and then they'll do the report.
Okay, now, once we're doing this, very good on that. Clear identification of product evaluated. Clear identification. Now, how do you identify that product? Is it a prototype? Has it got a serial number? Good chance it does. You want to be able to reproduce exactly the same conditions of testing this somewhere else. And that way you can actually get the information itself with respect to that. Now, who is attesting for the accuracy of everything? Remember, one of these problems that you have with respect to accuracy is that your individual measurement equipment, the transducers, the cables, a variety of different things have a certain amount of, frankly, the accuracy is not the proper term. What should we use in reality of the accuracy? What should that term be? I mentioned it before, uncertainty. Remember uncertainty. It's hard to make this transition. You might even well see the term accuracy used a lot in a lot of your documents. In reality, it's really uncertainty involved. So this is the guy that says guarantees everything's with this accuracy, and you do report what the accuracy is, or the uncertainty with respect to each of the devices you have there. Because if you don't have that information, you can never come up with the proper uncertainty for the complete test. Okay? Date of issuing. Date of testing. You know, the issuing, the accuracy and things like that. The actual date or dates. Be more appropriate rather than just say we started on this date, but we started and we continued. If you have multiple days going over that, you need to document those aspects of it. It's very important that you do that. And of course, name and location of the testing laboratory. In your case, Tom, what would you say? The laboratory in the basement, right?
Basement, or they call it the first floor.
The first floor. That seems a little more appropriate than the basement.
It has no windows, but it's the first floor.
It's the first floor. That's kind of like the, excuse me, man. That's kind of like the situation where we have that situation that I told you about at the atomic energy facility. It's only one window in the place. The rest is like being in the basement, frankly, whether you're 16 stories up or not. And then the accreditation status of the testing laboratory. You know, here's a real bugaboo, guys. You know, what can happen is the accreditation status is either there or not there. And so if you're going to use an outside facility to actually do the testing, make sure it's an accredited facility. Now, how do you find an accredited facility? How do you think you can find it?
Go to the person that gives the accreditation.
Could do that, or you can go to NIST. Are you familiar with the NIST?
National Institute of Standards.
Technology. Yes, it's very, basically it's like the old NBS, National Bureau of Standards. And in there they actually have a complete list of accredited laboratories for all kinds of tasks, including EMC. And of course, calibration instruments, the instruments used. Like you said, there's a question you got answered specifically. What happens if the instrument's out of calibration? Through everything before. In the Atomic Energy Commission, we found out everything happens and that you've got to retest everything that you tested before. Don't have to worry about that with pre-compliance. Now you're involved, Tom, with a lot of pre-compliance. And that's in fact what you're doing. How about you, Jim? Do you work with the pre-compliance a lot, or are you actually doing the final test?
No, it's pre-compliance.
It's all pre-compliant.
Yes.
But you're doing it to a degree that's almost like the actual test.
Yes.
Yes, I mean,
Where tests are.
because most pre-compliance testing, a lot of times is not using the specs themselves to do it, but using little other less expensive techniques to do it. But you're doing it essentially fairly adequate to the spec also, aren't you?
Right, but we'll go through levels. We'll go through prototype, then we'll go through engineering build, 1, 2, 3, as many as it takes.
Okay, sounds good. Now what we're saying here is, hey, where can you do pre-compliance? Well, you don't have to worry about, you can go to a parking lot. Except for one problem here, guys. Should this be a fairly empty parking lot or a fairly full parking lot? I would say you prefer to keep it around away from cars because it can tend to change that. Or warehouse space, the first floor in your case, first floor. You can see you have an antenna mask, and you have this mask and go up and down. You can actually make measurements. Usually with something like this, you're going to be at maybe 30 meters, 10 meters. And remember we talked about why it's at 10 meters? Especially with the CE specification. Why? That's basically the average distance of apartments together.
Oh,
Remember?
Yeah.
And of course, in the military, the mil specs, they can be 30 meters or 10 meters depending on the facility it is. And you can see from this arrangement here that it has an antenna, so you can be two things. If the device that's measuring it is a spectrum analyzer, we're looking at the radiated energy from the unit of the test. If you have an RF oscillator that's providing that, you can see that that's going to be subjecting that box to effectively radiation from a source. See if it's still functioning. Here's another pre-test immunity. ESD zapper, shattering relay, a variety of things like this. And you'll see you have a signal cable coming out. You take this ESD gun, you get it close to it, or even touch it possibly, and zap, and that information will go right down into the device under test. That's where I was saying you go down to Home Depot, remember? Buy one of those things that you light things with. You get the gas out, and it's a very inexpensive tester. Now you said, Jim, that yours looks like a cheap ray gun from a movie, right?
Yes, it does.
On that. So I guess you could buy those, but they're not that cheap. They're not really expensive, but they're not cheap.
I don't know what they paid for this one, but I know it was sizable. Right, approaching 10 grand for the system.
Or the whole system, or just the gun?
Well, the gun with the generating box, I mean, it's all in the system.
Yes.
It just plugs into the box.
So you're talking about anyway, now you go down and you buy the ESD gun at Home Depot or Walmart, and you're talking about $2-3. This is pre-compliance type testing. Now after the test, you need to know the DUT frequencies. You know the possible sources. Now, how in the world do you accomplish this? What device do you use to be able to look at the DUT frequencies, and that way you can kind of figure out what kind of where the sources are? What instrument is that? That's that thing that you said you should all have.
Spectrum analyzer?
Correct. A spectrum analyzer allows you to identify all these frequencies. Makes out pretty well from that standpoint, doesn't it? And of course, you need to isolate the source. Now, when you test this, like in the CE environment, you have to have everything around. But now we want to isolate where the problems might be. Remember, pre-compliance, you're trying to isolate the source to be able to get a fix for it before you send it out for complete compliance testing. And you also saw that one way to isolate the source was using the probes from Agilent that allowed you to take and eliminate the electric field and only measure the magnetic field. And they were pretty darn good. I suspect, I don't know about you, Jim, but are you going to go get a couple of those when you get back?
We need some.
Yeah,
So
you see what I'm getting at?
For sure.
That'll allow you to very quickly find and make troubleshooting changes and things of that nature. And so when you isolate sources, you tend to turn off accessories and other subsystems you're not using. Of course, if it disappears when you do that, guess what? Your problem isn't necessarily your unit. So it helps you figure out where the problem is. As far as now when it says isolate antenna, what we're talking about here is that parts, components, wires, traces, all these can become antennas. They look like antennas and things of that nature. Okay? And so therefore, you're looking where that happens. And then you disconnect cables, reconnect them. In fact, when we talked about the situation of taking and having cables coming in to a box, and you make a change to it, what did we say you had to do with that quick and easy way of checking it? Remember that had to do effectively with that spectrum analyzer and a circular probe, Fisher probe. You actually open it up, put it around the actual cable, and you checked it all the way down. You checked every one of the cables. You made a change. So then you did the same thing. So this is kind of like the same idea. Be able to isolate that. And hopefully you fix the thing at the source rather than creating a situation where you're acting as a Band-Aid. And then, of course, you use grounding, shielding, and filtering techniques. Always ensure that you have repeatable results. Can you do any good troubleshooting if nothing's repeatable? You cannot. That's the trick. And as you well know, if you're good at troubleshooting, they always call you in an opportune time, right? Like in the middle of the summer down to San Diego. Okay, so as far as the selection of the test house, notice the location. I guess you guys could go to the South Pacific to that guy I was telling you about, right? A couple of trip in with it. No, location needs to be close to you. You need to be able to tour the facility. You need to be able to go there and observe it being done at the same time. Not necessarily to catch problems, but what are you doing at the same time? You're learning. You're learning. You're learning how to do these different things. You're forming relationships. You're forming what I'd call a much better Facebook because you're face-to-face. And then, of course, you have the service, the equipment, and the history of the equipment, and other things you need to keep selecting that. Again, I was telling you about you can always go to NIST or other points. The accreditation bodies that exist do have a list of the actual accredited locations. Now, Boeing up in Seattle, in their Cal Lab, they probably have 10 or 15 different accreditations. So this is important. Now, why would you want to select a facility that's accredited versus one that is not?
Should be some form of standardization.
Absolutely correct. You can be assured they're able to perform the task properly on that. But there are niches out there, guys. Niches where these people really can do a great job, but they're not accredited. The way you find out about these is through your professional organizations or people you're working with and that kind of thing, by word of mouth. And it has nothing to do whether it's cheaper or not. It really has to do with that they do a magnificent job. And this more or less is showing you the different kind of bodies and the like accreditation to, you have the International ISO 17025. Most of facilities today are now ISO, aren't they? In fact, I think they're even more so. And originally when this came about, the ISO organization, it was really a voluntary situation. But a lot of companies now are insisting that you do that. Luckily for you, if you're ISO, then this course here has been part of the thing that helps you keep your training, doesn't it, on that. See the NIST handbook, US NVLP, NIST handbook? The neat thing about NIST is a lot of this stuff, this doesn't cost you any money. Because a lot of the stuff from NIST was produced by government money, so it's free. Okay? ISO is not. You end up having to pay for different things there. But lots of you have companies that support that organization. Let's see now. What happens here is that the auditing of things, ISO/IEC 17025, they're actually auditing the facilities and things of that nature, and they look at the organization, the management, the quality systems. And they insist that you have this. This is about becoming accredited and other things. The accommodations and environment that you have, equipment and reference material, measurement, traceability, and calibration. This is all important. Test methods, handling of equipment, records, any complaints that somebody might have had. This is all tracked. Is production sampling needed? Well, let's talk about that. In your case, Tom, would you be doing production sampling once you go into production?
Yeah, we do.
Okay, so effectively in your case, since it's more of an industrial product you sell lots of, you actually have to do production sampling, which actually means that somewhere along, maybe the next year or two, you pull 3 or 4 of these things off the line and you go through testing again.
You consider that auditing?
In a way, it could be auditing, but it's what you've decided to do to make sure that you're staying within the means. In reality, you don't have to really do it, but it's advisable to do it, especially if you're selling in the CE marketplace to protect your you-know-what. And notice that the USA is FCC. That's, oh, by the way, recommended for emissions, not a requirement. But wait a minute now. What are we talking about here? Once it's passed, we don't have to go back and do it. The FCC, the Federal Communications Commission, effectively is interested in one thing. And what is that? What's that one thing they're interested in controlling?
TV, radio.
Right. They don't want you to interfere with radio and television. So therefore, that testing is only for that purpose. They could care less whether the device that you produced works or not. In Europe, it's different, isn't it? They care whether it works or not. Interesting how that works. Then, of course, Japan recommends, it's not a requirement as far as the sampling. And in Europe, it is a requirement. How about that? U.S. and Japan basically actually say it's not a requirement, but it's recommended, whereas Europe says it is a requirement to do effectively the sampling to make sure the product is working. BCCI method. Do you remember what that stands for? BCCI? If you go back, does it go back? Yeah. BCCI is Japan, isn't it? Japan. And you look here, it says purchase samples in store. Now, we're not talking about going to the production line here, guys. In Japan, you actually go out to some store and buy it. Maybe a Walmart. And then you take and make measurements at a test site. And it talks about, is it clear of the tolerance levels? Hey, fine, that's it. That's the end of it. But then again, if it's greater than 3 dB, as far as this margin, there's a possible gray zone. So you actually say, all right, we've got a little possible warning here. It's sort of a gray zone. But if it's not, you're able to file a claim. Members are able to file a claim. Did it cause an accident? Yes. Fix it. Go start at the beginning. But the trouble is, caused by an accident. What happens if you caused an accident with this unit? Then you become liable, don't you? So what happens here is remeasurement required. You actually get the satisfaction. Eventually you make where it's acceptable. And this just shows you this is the sampling method they use in Japan. Why is it that Japan, by the way, uses so much sampling and statistics in their production? You know? Do you have any idea? Actually, right up there. As it turns out, for World War II, they were pretty wiped out, weren't they? So the U.S. sent a little gentleman by the name of Deming over to Japan. And Deming is a statistician. And he's basically the one that taught them all about statistics and statistical process control, which completely changed the United States manufacturing processes. It worked out real well. And they have a National Deming Award that they make. It's named after the Deming. They have a national award that they have for Japan. Did you know when the school kids start doing statistics?
A lot earlier than we do, I'm sure.
You might talk about grade school. They actually go out and sample cars and people and things like this and come back and do statistical analysis of it. Obviously, Deming is held in high regard, isn't he, on that? And what's neat about it is I got to meet the gentleman one time in a conference. And when he did his presentations, he was about 93 at the time. He actually had his birthday there while we were doing the conference. And needless to say, the speaking was a little hesitating and things like this. But you got past that after the first minute because you're talking to almost the god of the particular area. You tolerated that. So it was really neat to be able to listen to him. So anytime you get a chance to attend a meeting with these people, that's why I stress to you that you should belong to the IEEE and the societies you work with. It makes a big difference. Notice here that immunity retest can be expensive and can damage a unit. For instance, If you take and have to retest something, it's going to be costly, isn't it? Do you have any idea, Jim, how much it costs to do your test? Has anybody done an analysis from the, not just the testing, but the whole process?
Our pre-compliance test?
Uh-huh.
I don't know. They have a rate that they book our lab time at.
Yes, I understand. But what I'm getting at to you is that when you actually go out to be tested for real, not the pre-compliance, but the real thing, what happens is that the test may cost $50,000. And when we talked about pre-compliance, I showed you the video basically on the pre-compliance, that you go in and you can make a change and go back another $50,000. You go back and another $50,000. And that's what happened in your case, wasn't it, Tom? As far as your company was going involved. So they said maybe we should be doing some pre-compliance because of this. And plan for continued immunity compliance includes product quality, product critical assembly, control plan for critical assembly. All this stuff has to take into play. Items for product quality assurance plan. Of course, when you look at this, you're talking about ISO and a lot of other aspects require that, don't they? We actually have a responsible person, acceptable test sites, test configuration, test procedure, sample rates, plan of certain case of failure, reference to the critical assembly list and its control. So you've got to realize that you actually have to continue to do this throughout product quality control. By the way, this is a side here just to ask you. Isn't there one of the courses you actually go into this in more detail specifically?
Yeah.
On that? You have?
Our measurement uncertainty course.
You know, the measurement uncertainty course absolutely talks about that. But by the way, the measurement uncertainty course, just a little side here, is a course that you view it from this viewpoint as far as working with it, not from a mathematician. It's very, very different. When production changes affect EMI, guess what, guys? If you change the production method, you can actually, or maybe you have the part or item or a cable coming out of a different location. And what happens here is in the USA, FCC, it tends to be self-certification. So when you take and retest, you keep the test report on file. In the US, when you do the test to begin with, you have to send the test report to the FCC. See, that was one of the major differences between the European and us, effectively, is that we keep all the stuff for Europe. But when we're talking about FCC, you transfer the report to the FCC organization. USA, FCC, PC, or peripheral, and effectively, if emissions are worse compared to the last time. Now, here's an interesting situation. If emissions are worse, now you can see the value of the test plan, can't you? Again, keeping track of that, because with the test plan, are you able to repeat exactly the same test with parameters? It defines that, doesn't it? So you're able to redo the test in a very assured way. And of course, EC, Module A, self-compliant, AA, competent body, etc. Periodic retest specified in EN 61,000, series 55,000, 1100, and 55,022. CISPR 80/80 rule. 80% of mass-produced equipment must meet with 80% confidence level. So you actually have to use statistical aspects to be able to determine your ongoing compliance. Now, come on, guys. Would you do this with things you were building at Ball Engineering, where you're building 3 or 4 of a unit? No. This is all done on production equipment, things of that nature. Some of you may have in the past, and may in the future, actually do a lot of research, work in research, come up with that kind of thing. Now, this is kind of the typical thing here. I'm not going to go over the details of the statistical aspects. If you want to get really into statistical processing and that, there are courses and many books on statistical process control. In fact, the Japanese did this very definitely because of Deming's inputs. And the U.S. started doing this. You know what's interesting about statistical process control, guys? Have you ever done any research in it or looked in this area? At all?
The class I had to take in school.
Okay, then let's talk about that then. The class in school.
Oh, you're going to ask me what I remember?
No, I'm not going to ask you specifics, but what did they say the reason you use statistical process control for is? What is the reason? I won't put you on the spot.
No, you're fine. I mean, you can see general trends over the course
Look at
of
this.
production.
General trends over the course of the production. Which means that if you're doing this kind of technique and work, you're able to see something that's going to break before it breaks. Literally. You're able to see that, hey, wait a minute, another 100 items, this thing's going to be out of spec. It's an unbelievable technique. And there's a lot of companies that were working on that before the U.S. actually kind of shut down what I call their main manufacturing. HP had a group of people that went into manufacturing processing, and one of the products was statistical process control. And they actually marketed the guy's product. The neat thing about that product, just as a little slide here for you, is that the actual course was in Indianapolis. And the course happened the week before, effectively, the Indianapolis 500. So the guy that put on the course bought tickets for everybody to go to the, not the 500, but the qualifications. And you actually, pit passes. It's a really neat thing. I was the only guy in the whole group who stayed to go to it. The only guy. And that was a really neat experience. Really neat experience. So statistical ongoing compliance is very important. You can look at trends, so you need to think about that. We're not going to go through this exercise at this time specifically. You've had statistical process control. You probably had statistics, right? Is that correct at one time or another? But this is very different than most statistics itself. Here's a biggie, guys. Measurement uncertainties. Remember, a lot of people call these accuracies. The true term is uncertainties. Now let's take a look at the right-hand side of this particular chart. Gee, I haven't used any of the mechanisms right. I think I've hit this. Okay, let's look at this area right here. And start it there and proceed over to here. Just follow on through. I'll get better. And now I actually hit this, and it makes it a lot better for you. Starting on the right side, the antenna. I mean, I really don't have to draw a pointer to say that. The antenna, we have a certain amount of uncertainty with respect to the number. Remember, you had an antenna factor? That has a certain amount of uncertainty involved with it. That antenna, then, is going to take that energy, especially for looking at it, which we are in this case, and it's has to raise that signal up to a level that's within the input of the spectrum analyzer. So what happens is the preamp itself has a certain amount of uncertainty associated with it. So that has to be part of the calculation. Then it goes into the spectrum analyzer, and that also has an uncertainty. And then when it goes to the computer, it may or may not have additional uncertainties due to the type of calculations that are being done. See, the problem here is a lot of people don't realize, depending on the type of operations you make and the magnitude of the numbers you're dealing with, you'll end up getting the bigger uncertainties. For instance, if you have two relative sized numbers and you're doing a division, you might be 10% uncertain. So you've got to be careful. Most people consider the actual stuff inside the computer as being perfect. We'll assume that at this point in time. So what do you do with these uncertainties? Well, if you take a look at it and they're somewhat independent of each other, you can take the square root of the sum of the squares of these individual uncertainties and come up with a system uncertainty. It'll happen with this, okay? So you need to do this. You need to define what that is. And if you look at this and look at the sources of the errors or uncertainty, you might have a statistical property of it, which means you require more samples to get the mean value. You can see the sources of uncertainty are the antenna, the amplifier, now a lot of people call this the VSWR, voltage standing wave ratio. That's what it means. Cabling, any cabling that you're actually in the measurement process has a certain amount of attenuation, a certain amount of impedance. If you take a look at the typical cable you're using, it's 50 ohms impedance, but it also has capacitance, inductance, and things of that. OATS In fact, I believe, Tom, what is OATS? OATS, excuse me.
Don't know.
Outside. It's basically the outside facility that you were thinking about putting in.
Open air.
Yeah, open air test system. Hey, that's something you learned today, isn't it? Good. How about that? ATS. And the bandwidth properties? You have a bandwidth situation where you've got to concern that. How important is bandwidth with that spectrum analyzer when you're making these measurements? It's extremely important, isn't it? Extremely important. And of course, if you have an attenuator you've got there, and then you've got the calibration on top of it. That has a certain amount of uncertainty. All these factors have to come in place. And then you'll see you have the mean, let's say it's minus 7 dB, and the sigma 6.1. And the probability you're within that minus 6 dB is about 56%. You start adding all this stuff in. So you've got a problem that you need to do. Now, this is just a sheet. It's telling you you need to consider these things, and you have other details that you can accept. They have actually documents that go through that for you. Here's an example of possible error sources. We're not going to go through every one of them. Sergio, why don't you pick one of those and tell me which one, the information about it.
Let's see. Let's just pick signal generator.
Signal generator. That's down at the bottom, right? And you'll take a look at the source error of the signal generator. You'll notice it says 0 dB. Now, why? Now, how could that be?
Well, it says the mean, so.
Well, that's interesting. By the way, do you use something like a spectrum analyzer or a measurement device to measure the output of the signal generator? Yes. You don't turn a knob and come up with a value. The signal generator itself is generating a particular level, and you bring it to the right level while you're monitoring it with your spectrum analyzer. So therefore, the uncertainty is based strictly on the spectrum analyzer. What's this one here? Viswar. Actually, you could look here. There's a lot of different errors you might have to consider with that situation. Analyzer calibration errors are a part of the impulse, signal generator, and gain stability. So you've got all these errors that you're involved. By the way, you notice something about the levels. You've got the levels of the attenuator factor 0.5 dB. The Viswar minus 0.07, meaning there's a loss in this particular case. And what happens here is you end up having these possibly additive if they're dependent upon each other. So there's a lot of errors, isn't there? A lot of errors. Future trends in the United States. This is actually going through yes.
So, will a spec sheet tell us about these errors? Will it be put in words of accuracy, or how will it tell us that?
Sometimes accuracy, sometimes uncertainty. So what happens is that when you're taking every engineer is setting up your facility to test it, then you should be able to determine the actual accuracy and or uncertainty with respect to that. Where does he find the information? He goes to data sheets, maybe the calibration lab, a variety of different things to finally come up with it. It's like I wouldn't just say it's more like a jigsaw puzzle in a way. You've got to stick it all together in the right way. That tends to be one of the more difficult areas when it comes to measurement. So they're coming up, where are there measurement uncertainties in the system? Of course, what was one of the things that we actually used? Well, let's take a look at LISN. How about the LISN? Remember what the LISN is, guys?
Stabilization. Yeah.
Line impedance stabilization.
That's correct. Is that important? Now, you essentially with CE, right? Believe it or not, even mil-spec has a part of it where it uses the LISN now. That was one of the changes they made to F in that arena. So let's go on further and realize that, did I answer your question okay, Sergio?
Yeah. I guess it's new and interesting to me, so that's why.
Well, what I'm getting at is it's sometimes tough to find all of the information, and you have to really search for it. Then you have to put it together. What do you think some of the future trends are now in the U.S., specifically with respect to commercial, medical, and military?
wireless.
Wireless is one of the trends, so that indicates that we're going to have more and more problems, especially in the commercial arena, even from other sources that will interfere with it. But you also notice that the European Union is having influence a lot on how these specs are being changed. So the future trends, more wireless, even in the medical area. In fact, they're setting up now that they have devices in the human body that are wireless back to the doctor's office, or connecting essentially through effectively the internet directly, sending information back to the doctor's office, monitoring you daily or hourly or however it is. And they say, wait a minute, there's something going on here. Call them, tell them to get to the office in another 2 hours right now. So you see that connection being done. What about the military? What are some of the future trends there? A lot more wireless, isn't it? A lot more wireless. Let's take a look at it. How about the Predator? I mean, they're using those things all over the place now. But I mean, we look at that and it's very, very big. But we have effectively little robots that are remote controlled. They're no bigger than maybe a baseball these days. They're going all over the place. So we'll see that the interference becomes more and more important. Notice the European Union trends. A lot more information, telecommunications. They're being more involved in the automobiles. Now the automobiles themselves are nothing but what? Complete systems these days. And you're talking about multiple processors networked together, and a lot of the interference can in fact happen. So you're going to see tighter and tighter specifications. It's going to happen. And of course you have other trends in Australia and Taiwan. Because I kind of sort of thought that guy in the video we saw was sort of from Australia, wasn't he? You notice that? Just don't repeat some of the things he said about the box that he saw. All right. Any questions at this point in time? Any questions? No questions. Does that mean I can ask some questions?